Hello coders, in this video we will solve our next question from our LeetCode 75 list, and let me take you to the screen first. Yeah, here. We solved till here. Mm, reorder routes to make all paths lead to city 0, and today we will solve evaluate division, which is this question. So basically this question says that we have given equations in the form of strings in which uh, there will be content to string A, B, the like such strings, and A is basically numerator, B is basically denominator. Okay, and values. So number of equations is equals to number of values. Ith equation's value is equals to ith value. Basically AI, if this here AI and B, AB and BC, and values are 2 3. So they are saying ki this is A by B is equals to 2 and B by B is equals to 3. Okay, that's what they say. We have queries. So in queries, what they are asking ki they will give any two strings, and we need to find from that equation and values. Can we find answer for this query? So basically, we have given a like we have given number of equations, and we have given query. So can we obtain the answer for that query based on uh, the equations we have given that we need to find? So how we can do it? We have A and B, like basically we have numerators and denominator and its value. So numerator upon denominator is equals to some k value. So numerator is equals to k into denominator. Okay, that you understood. So let's take here first. I have numerator. So basically it is, they are saying ki AI upon bi, that is AI is numerator, and I have denominator, and its value they they give its value, that is in value I, and numerator denominator, these values basically they given if this in the form of string in the equation, and this value will be like, let's say some k, it's in double. So let's say k point over, just take k. So basically if it is like this, then numerator will be like numerator is equals to denominator cross k, and denominator is equals to numerator cross 1 upon k. So if we can see, we can make a graph like this where I can insert, we can make a string and string double, vector of string double, like such graph, in which I will insert k. Basically we will take its weight of that h from numerator to denominator. If I am, is basically like, let's say I have value of a, b, a, c, a, d. For everything, like a by b is equals to k, a by c is equals to m, a by d is equals to n. So basically a by b is equals to k. So it's basically depending, right? Whatever I'm using for the denominator, the value getting changed. So basically I have numerator, I have denominator, I have value, and I will insert those denominator in a like in numerators list, and also the numerator in denominators list with inverse value that we have numerator upon denominator. Okay, so yeah, that's how we will make a graph with, like, it will be basically like from, I'm going from numerator to denominator with this value. So this value, and from denominator to the numerator with 1 upon this value. So basically let's take numerator upon denominator is equals to k. I'm going from numerator to denominator, then I will get the k value. Basically numerator upon denominator, that's the fine. And if I'm getting denominator to the numerator, then I will get the 1 by k value. Basically denominator upon numerator. Okay, that's clear. So now you clear this, and we'll make graph that also clear, that we have equations and values. So first work our will be, we'll create graph. Now the real question, which is queries, and that's answer we need to find. In queries, what they have given, that ci and ji, like c and d, basically whichever. The query contains two strings, vector of vector string, and the in vector string we will have pairs of strings like a b c d e f, like this. So we need to find answer for that from the equations. Okay, so basically let's take we have a upon b, a, like I have a, and a upon b I have, and then I have this value, a upon b's value I have value of b by c also. I have value of b upon c, and they told me to find, like in query they told me to find what the value of a by c. Can I find it here? Yeah, I can find it. Like what they are asking me, yeah, I need to find a value of a by c. So what I will do here, I want to find a by c value. So here I will go for in A's list. I will see from a by something which value I am getting. And okay, if that something isn't my denominator, then go to in that something, like that node basically, and see if I do have I do have node there, that I'm finding, that I do have a destination there. I'll do that. Like here I'll go in A's, and if I find okay, I have a b, like I do have a value of a by b. Okay, then go to the b's, and while going to the b, like we can clearly see here, if I go in b's and if I see a b by c, then I have to multiply it, right? If I am getting a to the b, the edge weight something, like say ki its edge weight is, let's say ki I want to find a by, like not let's say, we have to find the a by c's value, and I'm at a, I found b in that list, and okay, I found b, then I will take the value, like that edge value, basically a by b, I will saying ki k, so I will take k, that's value, and I'm going in b now, like basically a by is equals to what, um, it's basically a and b, and I'm going in b, and I saw okay, I have a c value there. Okay, whichever value will be there, I will take that and I will go in that value. Likewise, I will do until I will get my denominator value. Right now, I have a c, I have a b, and in that b, I have c. So b upon c. Here you can see I have a by b's value, which I'm saying ki it is k, and for the b I have a b by c value, which I will take ki it's cl, and if I multiply I will just multiply it, then I can cancel it b, and like I'm saying just for left hand side, that which I took multiplication to get a value a by c, a by b into b by c is equals to a by c. So I have a value associated with b that I took here, and I have a value which was associated with c I took here, and as I wanted to go just c here, cause destination or numerator is just c, so what I will do ki, okay, I have a c, I have to return it now. I will return k by l value. Okay, we need to implement this, and how we can do it, we can say ki yeah, I'm getting node, and then again I'm finding which nodes are adjacent or directly connected to that node, and I'm getting in that node again. Likewise, I'm going again and again, so I'm doing DFS. So in DFS I need to maintain which nodes I have already visited also. So because what if I go in B and I will find A also there, right? Because there I will have A and 1 upon K value. I don't want to return from that, right? I will go like basically you can think like I'm going to A to B with K edge value, and why do I want to return from B to A? Because I want to search for the C. So I will not return to the A, though like they may have said A by A. So what if they have said A by A? Okay, I will return it. Like A into A upon A is equals to 1, and in that case also, and if I go in B, like while going I will take the age value which is K, and while returning I will take the 1 upon k. So k into 1 upon k will be 1. So we'll first check if my start is equal to destination, like the node which I'm visiting, which would be that say ki it is the start. Start is equal to destination. Yes, then return the product. Else, insert that start into my set and don't visit that again because I already visited it and I don't want to return again. If I wanted to return, I already checked ki do that will the node I'm on which that's what I wanted or not. If yes, I wanted that node only, then okay, yeah, I will return the product. And after that, I'm inserting that value in stack. So yeah, that's what I wanted to say. And let's solve the let's code it. And while coding, I will tell you why we are writing such things, and you will understood through code also. Okay. So let's write the code. First, what I said ki we need to create a graph. So to create a graph, what I will do ki I will declare the graph publicly so that I don't want to pass that graph variable at which will be really big. Like that data structure will be the big. So I don't want to pass that again and again in in DFS function. So yeah, I will write one graph structure. Graph structure will be it will be like this: map of string and vector of pair of string and double. So basically I will have a value here, and based on whichever the denominator I will get this value here. Okay, and I will say it is my graph. So basically if I'm going from this to this node, then I will have this edge node, this edge width. Okay. Oh, so I will first make graph. So for that I have n is equals to equation dot size and value dot size will be the same because number of equation is equals to number of values. Equation dot size, and for I is equals to 0, I is less than 1, I plus plus. What I will do, keep I will say ki my numerator is not int, it's string. String numerator is equations I at 0, and string denominator is equation I1. And value we need to take, which is in form of double. Value is equals to value values at I. Okay, so now I will insert it graph of numerator. If I'm going from numerator to the denominator, then I will have value as it is, which is if I'm going to the denominator with value v, and if I'm going from denominator to the numerator, graph of denominator, basically from denominator to the numerator, push back numerator with 1 on v by v. Okay, this much is clear. Then we'll write, we need to return vector double, so okay, let's copy it from here. Vector double answer, and we'll take query and secure to query here. From queries, and in queries also we'll do the same. Denominator and numerator will take numerator with this query 0 will have numerator and query 1 will have denominator. Oh, we took this. Now what we want value, like we want answer. So what first they have said key if or if a single answer cannot be determined, return -1.2. Okay, if we can't determine then we need to return minus 1.0. And when we can't determine, can you tell me? Like, first observation is, if we don't have those numerator and denominator in our graph, then how we can find it, right? It's not numerical value, right? It's a string. So if we don't have that string in my graph, then it's unknown for me. I don't know the value. I don't. So if it is not, my numerator is not in graph or the denominator is not in graph, then I will just push minus 1.0 in the answer, and I will continue. So what I need to write the condition: if my uh, graph dot find numerator is equals to graph dot end, and graph dot find denominator also, or not and, any one of us, if we don't find, then we will return, not we will return, we will insert minus 1.0 in the answer. So graph dot find denominator, it is also graph dot end, then answer dot push back minus 1.0. That's what they have said that we need to give for that answer, that for the query. Okay, then we need to continue. Else what we need to do, we need to find the answer. So I will say ki double find the answer, or we can say the result is equals to do the DFS traversal from numerator to the denominator. Before that I need to take another set for to store the previously seen strings, which is, we can say the new nodes, the previously seen nodes. To store that nodes, we will take set, and unordered set of string st. Okay, denominator numerator will pass say yes st, and will send 1.0 to just maintain the product. And if basically, or whatever the result it is, we will just insert it in my answer, and then we will return that answer. We need to write the DFS function. So we'll go here, and it's kind of, it return type will be double. So yeah, I will have the string numerator and string denominator, and another set st, and this is basically product. So I will say it is product. And what I will say, if what we first found here, when I went from B to C, okay, the C, but the C was the one which I was finding. So we went to find, and then I saw. So what I will say, my numerator is equals to denominator. Numerator is equals to denominator. Then just return the product. I found it till now. Return the product. Otherwise, what I will do, I will insert insert that numerator. And what I will do, for I will just take auto ID from graph of that numerator, and I will say it is my next node. So I will say string my next node. And next node is equals to id dot first, and my weight, basically to go to that node, what the, or we can say the next denominator or new denominator, new value. So we can say for that numerator I will have new denominator this, and I will have new value, double new value, or you can just take weight of that path, or I will take new value or weight I will take new value. new value is equals to it dot second. Then what I will do कि I will just see कि first I will say कि it was, did I found it before. S dot find my new denominator. Did I visit it before? S dot is not equal to S dot n. It basically means कि I visited it before, so I don't need to go again to that node. Just continue it with next node. And if it not visited, then what we will do कि we will say कि okay, find the answer with, take that node and find the answer, and with that value product that new value with my already product whatever I had till this function. So I will say कि answer is equals to DFS with this new node, with this new denominator, and the denominator which I actually want, that I sent then, and the st, take the st and the product which I have till now, and cross the new value. So basically it is multiplication chain. You get it right. That's what we are doing. Like a by b into b by c into something like what if I want a by d, then I have a by b into b by c into c by d, such values if I have. I'm doing multiplication chain. So product into the new val I have with that new denominator that I will take. Okay, and if that answer is not equals to -1, so basically I found numerator and denominator, that the denominator that I wanted, that I found, and I got the answer, so I will return that answer. Otherwise we'll go with the next node in that new, like next denominator in that list. Okay, and till like I don't have any next, like I don't have any denominator with I can find the denominator that they wanted, then I will just return -1, 1.0. Okay, so let's run it. Just submit it. It is accepted and it's 100%. Okay, so let's see how much time complexity it's taking. It's taking big of, like I'm taking worst case in which we have complete, like what if we have whole connected graph, like connected graph, whole connected graph, complete connected graph, like we can say, in which one node is connected to all nodes, and we will, like basically n, if you have one node, n nodes, it will have n minus 1 edges. If you have in such cases, to make graph it will take big of n square time complexity, like here and here also. For every queries, let's say we have m queries, we will, worst case will need to visit all nodes, so m cross n, that will be the answer, like m cross whichever the biggest, like m cross n or n square, whichever the biggest, big of m cross n, maximum of big of m cross n, and big of n square, that will be the time complexity. And what will be the space complexity here? The space complexity, I will take this only, that I'm taking this graphs because it is the most, like most space taking thing which is we created, string and vector of pair string double, so it can take big of n square, because what if we have connected graph, so time complexity in space complexity as both are big of n square. Yeah, so that's it for this video guys, and yeah, we'll meet in next video. Till then, bye.